We will now go to our performance tasks number 5. So for this second semester, we'll only have 6 performance tasks. So this is the second to the last performance tasks. So for today, for this day, we title our performance tasks number 5 as resistors in a circuit. And our objective for this performance tasks is to verify the different principles that governs whenever we attach resistances or resistors in either series connection or in parallel connection. So we know that there are 3 governing principles for each of this. So that's the one that you are going to look at and contemplate upon. And we will have for our materials or for the things that we need for this activity, we will use the PhET simulator that is found in the net. So the link is provided for you for this activity. Now we will be seeing the app later or the simulator. But let's just run through with the activity for today. So among the things that you are to have is number 1, you have to have a diagram, of course, not taken from the simulator that we will be using. So once you have your setup there, you can arrange the things that you need into a circuit diagram, and then you can probably capture an image of that and post it here. Now for the procedure, of course, I'm going to detail the presentation of the activity there, so you can have a procedure. Now with regards to our data, so there are 2 sets of tables that you are to complete, and among the values that we'll be having here, so you may decide to set the same values for R1, R2, R3 for both tables. But of course, you have to get a corresponding voltage or the value of the voltage using the voltmeter and the ammeter. Now, these values of the voltages and the current values are to be taken from the voltmeter and the ammeter that you have. So these are the ones that that will be taken from a set of reading. So except for the resistances you have to set it. So from trials 1, 2, and 3, you may have these different values of resistances, R1, R2, R3. Now for your R total or R sub T, you may calculate that, and of course you have a corresponding equation whenever you are dealing with a series connected resistances, and you have also a way of calculating the total resistance whenever you're dealing with a parallel connected resistances. Now again, for both tables you may use for R1, R2, R3 exactly the same values, but again, the suggestion will be that R1, R2, R3 must have an increasing value from trials 1, 2, and 3. So you have to set your R1 in an increasing manner from trials 1 up to 3. Now the same is true for R2 and R3, but you may copy the same values here whenever you have your parallel connected resistances. So again, the value of the voltages and the currents has to be taken by using the instrument there, or the voltmeter and the ammeter readings. Now you have to complete as well your discussion, observation, analysis, and including the conclusion. So there are 8 parts in the activity, and right below is your rubrics, how you will be graded for this activity. So we've been using these rubrics for quite a number of activities already, and this is the one. We will be using this for this activity as well. Okay, so now this is our interface. This is the PhET simulator. So this is our circuit construction kit, and we call it as the circuit construction kit AC. And maybe, you can either click the lab. No, there's an option here for lab or for RLC. So RLC refers to the resistor, inductor for L, and then C for the capacitor. No? So this simulator is will allow us to even connect capacitors. But in this activity, now let's break down the things that we will be needing here. No? Okay, now among the things that we'll probably need is to our batteries, or maybe a single battery, and of course you can rotate the battery to line it up, or to arrange it in a particular position. So you can hold the tip and rotate it in such a way that you can position it in a manner that you would want. We will need some wires. So this is our wiring. You need some resistors, and maybe you'll need 3 of this for the first setup. So you can drag 3 of that. And likewise, you may probably need a switch. Now, among the things that we will also need here is our ammeter. So this is a picture of our ammeter. And basically, ammeters are typically attached in series. So whenever you have an ammeter, you can position it in series. But this one, this type of ammeter, can simply get the value of the current by simply positioning it in a device. So maybe we will see how it is used later. So we need an ammeter. So here's our ammeter. Now our voltmeters are designed whenever you use them, they are used in a manner where you will connect it in parallel. So if ammeters are used in series or connected in series, typically voltmeters are connected in parallel. So again, among the things that we need some wires. Any device that we would not use anymore, we can put it back now, and we can select another one that we will need. So we have a switch, we have a battery, we have wires here now. And the first setup that we will be having is our series connection. So maybe we could have this as our R1, the first value. You could have the next resistance as R sub 2. And maybe this next one is your R sub 3. So you could then connect them with some kind of a wire. Then we need we need a switch here. So maybe we will use a wire to connect this switch to our battery now. So the battery and the switch are now connected. We can open it now. And we can extend this now and have our so again, this is R1, R2, and then maybe this is our R sub 3. Now between our R1 and R2, we can connect a wire. And next, now we could also have this and connect it to our next device. So basically, this is a complete circuit. Now, if we want to change the value of our resistance, we can click the resistance or resistor, and we can now slide this to increase its value. Now, you will also notice that there are colors that are changing whenever you change the value of the resistor. And if you remember, we have some color coding method last time, and that will also match with the right value of the resistor whenever you have a particular color there. So that's how you change your resistor. So resistor values or resistances must be increasing from trials 1, 2, and 3. But maybe for your 2 tables, for the series and the parallel connection, you could have similar values for your R1, R2, and R3. That is if you want to use the same values. Now for the battery, we can also increase or change the value of the battery. So maybe we can have some what, 40 volts. So by simply sliding this, we can now set the value of the voltmeter to 40 volts. So you have your R1 again, R2, R3, R4. So for our R1 value, we could have maybe the lowest value that we could have here, maybe 8 ohms. For our R sub 2, we could have some bigger values, like 16. And then your R sub 3, you could have some values like, again, 16. So we have here, again, 8, then we have 16, and then maybe we can simply vary this to maybe 13. And we now have 3 different resistances. So for our voltmeter values, so if you want to get V1, you can position the voltmeter here on this end, and maybe you can close the circuit so that you'll be able to get a value. Now, whenever the value of the voltmeter becomes negative, then all that you have to do is to swap the position of the electrodes or the lead. So you can exchange it, and maybe you can now have a positive value. So meaning, if we simply interchange the value there, then we can have a negative value. So these are V sub 1. If you go for V sub 2, you can position it in another location like this. So this is your V sub 2. Now for your V sub 3, maybe you can position it here. And we have some values 14.05. Now you may record this. So this 2 V3. And if you want to get your V total, you can have the voltage across our battery, or maybe somewhere here, and put it there. So it covers already the 3 resistances. So you could call this now, from this end to this end as your V total. So again, while you have your V1, so this is our V sub 1, then you can record that value. Again, sorry, so we will have to make it positive. So this is our positive value. Now you can also record the value of the current. So how much is the current here? So from our I1, you can call it as I sub 1, the current that enters your first resistance. Then maybe you can go to I sub 2, I sub 3. And maybe this is your I total, the one that gets into the battery or gets out of the battery. So your total current may be the one that you will place near the battery. The one that you can put in your gadget, in your resistances, will be your I1, I2, and I sub 3. Okay. So again, if you will examine again our table, we will see that one. Now we will have a setup of our parallel connection again. To get to have values for the next trial, you can keep the voltage the same, but you can now increase the values of R1, R2, and R sub 3. Okay, now let's have a parallel connection. So that's how we do the series connection. Now from our initial setup, you can possibly use some kind of a you can cut the connection. So you will have there a way of creating your parallel circuit. So we will now connect our resistances in parallel. So maybe this is a way of connecting them in parallel. So let's detach this. So we are able to remove this wire below. Now 3 resistances are connected in parallel now. And maybe we can still make use of our wire and our switch. And probably we'll need some wires here so that we can straighten this one. So let's just use that. No? So we will have to so maybe we can connect this one. Let's just use some wire again. No? And let's connect this. No? And we will need one more wire no, to be able to complete our parallel connection. So this is how we set up our parallel connection. You can see the schematic diagram for this. No? So we have a battery and then 3 resistances with a switch. No? But in an actual gadget, maybe we could have this one. No? Now still our voltage is at 40 volts. No? And maybe our R1 is 8 ohms. This is 16. This is 13 ohms no, for trial 1. No? And now, no, again, no, what we will be getting are voltages. No? So we need to get the value of V1, V2, V3, likewise the currents no, in each of these resistances. No? So this is I1, I2, I3. And then maybe no, near the battery is your total current. No? So maybe now we can close this and therefore now we are ready to find the first voltage. No? So this is our V sub 1. You can record that, no? Then you can go for the next value, no? And so on no? Until your third no? Value V3. Now for your V total, maybe you can have it here no? Across the battery here. No? So this is your V total, V sub T. And then you can record the values there now, depending on whatever value your voltmeter records. No? So this is for parallel connection. Now for the current, no, you can check the current for VI1. No? Next, you can check the current for I2. Then you can check the current for I3. And likewise, you can check the total current, no, I sub T. No? So the one that goes near the battery may be considered as your I total. No? So again, no, I total, I sub T, I1, I2, and I sub 3. No? Okay, so I think now this type of a ammeter now will be very, very suited for our activity. No? So again, now don't forget to get the value of the voltage as well. No? So you can avail of this simulator whenever you open it up no? In the FET no? Website. No? So the FET website is provided for you. So basically, that's it. No? This is the simulator that you will use both for series and parallel connect. Okay, as a kind of a reminder, so from our table that we are to gather again, no? So we've seen no, the voltmeter and the ammeters there. No? So the voltmeters will be used to get the voltages. So all of these voltage values are to be taken from the voltmeter readings, no? Starting with V1, V2, V3, and V total. No? Now for your current, no, again, you are to get I1, I2, I3, and I total. Now the only value that we will calculate here is your R sub T. No? And R sub T equation or formula will depend on what type of connection you have, no? Whether you are dealing with series or you are dealing with parallel connection. No? So please don't forget how to calculate your R sub T, no? Given the kind of connection no? That is specified. No? So but R1, R2, and R3, you will be the one who will determine it no? In your group. No? Your group members will have to decide no? What are these values, and you are to copy or have similar values both for the data in table A. No? So this is A series connection. And then maybe you have to use the same values for R1, R2, and R3 in table B. No? And I think now you are ready now no, to perform your performance tasks number 5. No? And God bless everyone. No?